You should do that at the end. Maybe you don't like the talk, and you have already given me the clap of hands. Okay, so my name is Mario. I work at Bloomberg in the Python infrastructure team at Bloomberg, and I also work with Juanlu at PyCon Spain and some other PSF organizations in London and in PyCon US. But today I'm here to speak about logging. And the reason why I'm here to speak about logging is because I think it's a model I really like. I really like the design of logging. Ideally, I want to transmit that feeling to you after this talk. But I think it's also a model that if you get to know in deep, it's much easier to work with. So if the clicker works. Yes, great. So we are basically going to see why logging is important. We're going to see how it works, how can you use it, how do you configure it, which I'm sure many people here have had pain with. And then we'll see some of the code of the logging module itself, and also use some kind of standard recipes or more advanced recipes that you'll be able to understand even if you didn't know anything about logging. Ideally, after this talk, you'll see some advanced use cases that you can do with the logging architecture. And then we'll have time for Q&A. So first of all is like, why logging matter, right? Why should we log at all? And the thing is, this is something that many developers like underappreciate until you have this beautiful problem in production where there's no way to know, because your process is just a black box, right? When it's running in production, you cannot know what's going on. So you can see logging as the documentation for the person that's going to go and try to see what that process is doing. And then if we instrument our code with logs, maybe whenever there is an issue and you enjoy your holidays in Cyprus, maybe that person that's troubleshooting that won't need to call you to fix it, because they will be able to understand what's happening in the process without knowing the code. And you know, something someone told me, and I never thought about it, is like, so there are some purists around logging that say you should never use a debugger in development. And the reason behind this is that if you are not able to reason just with the logs that you see of your application in development, which includes like debug logs, for example, how will you be able to understand what your application is doing in production when it breaks, right? I'm not that crazy, okay? I think I still use the debugger, but I do see the meaning of it. I think that I'm trying less and less to use the debugger. I still use it in some use case in some scenarios, but I think it's really important that we are able to understand what's happening in our application in depth just by the logs that it emits. And you know, some people might say like, "Hey, but we have print, right? Why do I need logs at all?" And you know, whilst it will still print things to standard out, by using logging you get many more things. You get multi-threading. You get a much more flexible tool, as we're going to see in the following slides. You get categorization. You get something really nice about logging is that is some kind of a collaborative. Some kind of a collaborative framework. So basically, it allows different parts of your application to just say what they want to log without saying how it should be logged. So as we're going to see in the following slides, there's one part where you as a user say, this is what my application is doing. And then the person that's going to run that program is going to decide how things are going to manifest in your system. OK. So first of all let's see how logging works and what are the different parts of it. Does anyone here do Java? Don't be shy. No? OK? OK, cool. If you have seen log4j, basically the architecture of logging in Python is just copying the same just copying the same design. So the parts that we're going to see are the same that are in log4j. And I'm going to go through all the elements of logging, so you have some kind of base understanding on how to use everything. And the first one is the logger. I'm sure all of you, if you have logged anything, you have used Logger. It's kind of your magic tool that you use to log anything you want. So Logger is just that class that you use to log something, right? So then in your mind model, you might be thinking, when you're interacting with logging, you might be thinking of something like this, right? You have a logger, you call .info, and then you pass some kind of a base string with some arguments. And then this goes into your logger object and magically appears into the console, right? It's so nice. But we know this is an abstraction, and what's happening behind is that when you send that to your logger, what's happening is that it's something is being created, and that's called a log record. Now, log records are key when we are trying to understand logging. Log records is basically a package that's being created with all the information at the time that you log. But you cannot just print a log record, right? So what's happening is that that log record is going to go to a handler. So what's a handler? A handler is basically are types of classes that are defined in the logging library. You can also create your own that just take a log record and they emit it. Each log handler will emit the log record in a different way. So you have log handlers that will just shoot things to a stream. You have log handlers that send things to a file. You have also file handlers that can rotate itself or that can compress itself. You can send logs via mail. So you can have a log handler. So you can just use the logger and then have a log handler that will send all your logs via email or via HTTP or just to a SIG-log or to a socket. There are a lot of log handlers that you can already see in the standard library, and you can also create your own. Okay, so now we have a better picture of how everything works, right? We tell the logger we want to log a message. It goes to the logger. The logger is going to create this package, and then this package is going to be sent to the handler. That's going to handle everything, right? But how is that package transformed into a string? That is kind of the most common things that a handler will do, right? And that's where filters comes in. So filters will mix your package and usually transform it into a string. Basically, the most common use of a formatter is that you give them a format, which just like a string template with the attributes of the log record, and it's just going to transform everything into a string. So now we understand how logging works, right? So we have a logger, we send the message, it goes to the logger, it emits it to the handler is going to use a formatter, and then it has a string that it can send, for example, to the console. Now, for being precise, I have to introduce one more thing, which is the filters. So filters, I won't get into too much detail, but in case you need some advanced use case at some time and you want to use a filter, filter just allows to do some kind of fine-grained filtering of your logs. It's basically one more piece that we can see now in our workflow. So logger, it goes to the filter. The filter just says whether it should emit the log or not. Then we go again through the same thing, and then the handler can also have a filter, so it's gonna check everything again. So now we do really have an idea of how it works, right? There's one more thing. So there is the nice hierarchy of logger. I really like this picture. So there's this nice hierarchy of loggers that you can create when you ask for a logger. So this is the way that you create a logger. So basically, all you do is you ask for a logger. If it's already created, you're going to get the same. It's just a singleton. And what you're doing when you do this is you are referencing or creating a hierarchy. So all loggers have all loggers have a parent, and when you create it like that, you can just split things by the dot. So basically, this means that we are creating a logger called child that has a parent called parent, and then all parent loggers have the root logger. So basically, you have this hierarchy, and what the hierarchy does to you is, if a logger doesn't have a log level set, it will look into its parent recursively. And then this is a thing, probably the biggest gotcha of logging. The other thing that the hierarchy is used is that when a logger is emitting any log, what's going to do is going to go through all the handlers that it has and emit the log through all the handlers that it has. And then it will go to the parent and recursively do the same thing. But this is done at the handler's level. So what I mean with this is a logger is not going to tell the parent logger to emit the record. It's going to tell to the handlers of its parent to emit the record. We'll see in the future what that exactly means, but this is something that most people get confused with configuring the logging stack. Okay, so we now have an idea, right? We do know now how logging works. We are now experts of logging. So we have the logger, it goes to the filter, and then we have the handler, which has a filter and uses the formatter to string things out. And then we said that, okay, once we are done with with all the handlers of one logger, we're gonna see if there's an attribute that all the loggers have, which is propagate. And if propagate is true, which is the default, it's gonna go and look for all the parent. It's gonna look for the handlers of the parent recursively and tell emit log to all the parents of the handler. Everyone understands logging, right? There are some more things in this workflow that I have to show you. Just the last one, okay? I promise this is the last one. So there is also a category that will like this. This is kind of the level that you set in your logger to filter out. So you can say like my logger will only log from info and above, nothing lower. And then there are also some attributes here and there are some switches to control whether you want to disable a log or something like that. This is for real, the actual workflow. And this is documented like this in the Python documentation, but I think it's much, much easier to go step by step understanding each of them. Because the first time I look at this one, I was like, okay, I'm gonna go and read the code instead. Okay, so now we know how like the different pieces of logging, but let's see how do we actually use like this huge piece that we just saw, right? And the thing is, it's really simple, I would say, how to use it. So here you can see kind of many different features of logging and how they are used. So you can see we're just importing logging. We get the logger with name. We'll see in a little bit what that means. And then we log something in the bug, right, because we want to get some information in case something goes wrong. And here, this is just a placeholder for the attributes that you're going to put afterwards. You pass those arguments. And then, we're gonna run a function that we know that it might raise. If something goes wrong, we're just gonna log an exception. If something goes wrong in a general way, we're just gonna say, hey, there was an unexpected exception. This is amazing. I loved it when I saw it for the first time. This is gonna log all the stack information about the exception and also the exception type and the name of it. And then we're just gonna erase. And then if in some situation we want to log a message and also log the stack information, you can just do it with stack info. So the categories that are in logging are fatal, error warning, info, and debug. You can just have attributes in the logger to use them. And then exception is just basically error with x info equal true. It's just handy. Okay. So now I'm going to show you some things that I've seen in logging and I've done as well before, and that I think there are better way to do this. How many people have seen this line somewhere in their code? So basically there's a login.info and they put the exception here. Yes, and I hate it when I say this. And you wonder, why do you hate this, Mario? And the problem is like if you catch a general exception, this exception might be a key error. And what this is going to do is just going to log the string representation of your exception. You know what's the string representation of a key error? The key that's missing. So if you have a dictionary, you try to access to a key named data, you're going to have a nice and very informative error saying, a terrible error happened, data. How is that useful, right? What you really want to do is just what you want to use xinfo. This is going to log the stack trace of your exception. It's going to log the type of the exception and then the string value of the exception. So this is much more useful when you're trying to debug your problem. Sorry. Okay, let's see more. Many people, you might want to do it in some situations, but quite often you see people declaring getting loggers like this. And what this does is you just create the logger with that name, right? Which is a child of the root logger. But what quite often you want is you want to base your logger hierarchy in your module hierarchy. If you use name, this is like a super common pattern. What you're doing is you're saying, I want my log hierarchy to follow. Sorry, it's too early. And so this is going to follow your file hierarchy. So this means that, for example, if you have a module name Django.super request handler, the logger is going to be Django super request handler, but it's going to have as a parent Django itself. So it will allow you to configure everything at the level of Django. In brief, unless you have a really good reason, always use name. Then this can start wars of the size of Vim versus Emacs, but I have to say it. So when you are creating a log record, usually the way that log is the logging stack expects you to do it is like this second one. And the reason for it is that because we saw there are all these many switches, if you do this string interpolation is only going to happen if the log record is going to be emitted in a handler. If it's not, you will save that price. It's true, and many people will argue, don't do this because maybe something breaks at the time of a string interpolation or you're hiding a bug. But my recommendation, if that's your fear, is whenever you are testing, because we are all testing our code, right? Just test everything in debug, and then you won't have that issue. Then, this is a personal battle I have. If there is something I want you to take away from this, is this. Like, when you log an exception, okay? Well, when you log in error, in fatal, I personally also think the same for warning, but that's debatable. You are transmitting an error to your user, okay? If you log an error, you're transmitting an error to your user. If you then raise, you are transmitting another error to the user. So what this means is, if you do this, which is log an error and then raise, you have now 2 errors. And quite likely, maybe your caller is going to catch exception, and as it's in the sign of Python, if you silence an exception, you should log an error, right? So now you're going to have 2 log errors. So just log in info and raise the exception, or if you're logging an exception because you don't want the error to be propagated, then don't propagate it. But don't log an error and then raise, because then your user has 2 errors to handle. And I've used libraries that had to turn off the errors because they were doing things like this, which I find extremely painful. An example is there's a database API that I'm not going to mention that logs a warning whenever it fails to insert the record because, for example, it collides with a primary key. Now I have a use case where I want to try to insert something, and if it doesn't work, it's all good because I know it was there. It's a normal use case for me, right? But the library is logging a warning, so now I'm forced to turn off the warnings just for that, and because the library is logging a warning and they're raising an error. So, don't do that, please. Okay, so now let's see how can we configure the logging library, right? Basically, there are 3 ways to configure the whole logging stack. You can do it yourself via code. You can do it with what's called did-config, that basically you can pass a dictionary, and you can also use a ini file. So the first of all is doing via code with a helper. It's called basic config. You just import logging, call basic config, and you can pass a series of parameters, as we can see here, that allow you to quickly get everything configured out. It's kind of a really simple default, configuration to be used. This is basically going to send everything by default to std, and the default level is warning. Is kind of thought for things like scripts and the like. You have a lot of options that you can just pass around. Then the really verbose did-config, but really precise, allows you to get all those objects that we have seen before and configure them one by one. So for example, here we can see that this did-config is going to configure a formatter where you can see this is the format that we passed to the formatter. So what this is going to mean is when the formatter gets the log record, it means, hey, put the time here, then put the name of the level here. So that's going to be, for example, info, error, or whatever. Put the name of the logger here, and then just put the message. There are many attributes you can see in the documentation, and you can configure however you want. Then it's saying create a handler called console, which is logging on info. It's using the formatter that we just defined. You can see we are referencing here. It's all with strings. How beautiful is that? And then you can just say the class that it is. So this is just a string handler because it's going to log to the console. And then we can configure the loggers. This is the standard way to say this is the root logger. So basically we are saying the root logger is logging everything in console. Sorry, everything is logging everything in info to the console. And then we're going to define these plugins logger that's going to log on error because we don't want it to be so verbose because it may be logging too much in info, for example. Okay. And Then you may wonder, how do you configure things? Ooh, I have to fly. You might wonder, how do you configure things with the ini file, but I don't like it. I usually just use YAML, so I'm not going to show it. And I'm going to go really fast. I might have to use some time from the questions. So we're going to see the code of logging. I think it's the logging module is easy to read, and if you have time, go through it. I have to say, the design of it is really beautiful. The code feels old. It's because it's old. It's using camel case, as you can see, like basic config, get logger, and things like that. And there are some talks about kind of putting a lot of effort into it, but still the design is beautiful and it's easy to understand. And we're going to see what happens when we do .info. So we understood everything, but we're let's see if it's real, right? So this is logger.info. This is the code logger of info. This is basically the first thing it's going to check if the logger is enabled for it. So it's going to check, is the logger enabled for the info? Yes. Then we go into logger log. Then into logger log. So I'm going to go really quick. Then there's a function called _log that we can see here. And this is what we mentioned before. This is make record. And as you can see here, this is extracting all the information about the current frame that you are logging things from. So this is getting the name of the logger, the level of it, the function name, line number, message, arguments, everything. It's going to put everything into a package, into just an object, and then it's going to call handle. That's going to pass it to another function that's going to do the handling of it in the logger. So we're still in the logger.handle, and the first thing it does is it's going to check if I'm disabled or not, and I'm going to use the filter to see. Well, I'm going to use all the filters to see if I should log this file or not. If those check passes, then we call a function still in the logger called call handlers. So call handlers, all it's going to do is it's going to iterate over all the handlers of the logger, and for each of them, it's going to check if the level that they have set is still like higher, well, lower than the one that log has, and therefore it should be logged. And if it should be logged, it's just going to send that log record to that handler for you to handle it. And now this is what I was referring before. If you see in this code, it's not calling the parent logger. It's going through the handlers of the parent loggers one by one and using those to log, which is not the same. So that's the cpropagate that we saw before. If cpropagate is set, you can see that it's getting the parent logger and then calling handlers on it. So now within the handler, again, we have the filter. There are some logs around it to ensure that multi-threading works. You don't want your logs to be all messed up. And then it's just going to call set.emit. And that's up to each handler to decide what emit means. OK. Let's fly through some sample recipes. OK. If you have read the 12-factor app, you don't agree with these slides, with this slide. But I have my web app that I run on a server that's in a corner of my house, and I love to have this, just in case it's useful to you. If you have an enterprise deployment, don't use this, but if it's some kind of a personal project, I find it super useful. So at my home, what I have set up, for example, is there's a part emitted from here from the dit config, but what I have is, hey, for requests, I want to log everything in the back, so I want to see all the requests that my server is sending, and then I'm going to have multiple handlers. So I'm going to have a handler. I'm going to have a handler with info, another one with error, another one with the bug, and then I have another handler which basically just mail me if there is a fatal error. So the way I have configured this is mail admin is just an SMTP handler. So whenever there is a fatal error, I get the mail immediately because I want to check while my server is in fire. And then I have an info log file, which is just a rotating file, and the same applies to the other. Why do I find this useful? Because I have maybe half a day of logs in the bug. So if there is an important issue, I can just go and check it out. I have a big history of errors, so I can check if an error already happened. And then I have like maybe 1 week of logs in info in case I want to see if something else around. Now, you want to log JSON, you can just do it like this. Basically, all you do is you get a formatter, and then you make the formatter print everything to JSON. Do you know how much time we still have? OK. OK, I'm going to fly through them. The slides are going to be online. OK, sorry about this. If you want, let's say you want to add some, for example, contextual information to your logs. I love this. So you have, you use Flask or whatever, and you want all the logs that are related to one request to have some kind of a unique ID. Something you can see here, for example, is you can just use a function that's in Python 3.4, I think, is set log record factory. It allows you to set a factory to, so whenever you create a log, you can add your own attributes, and then you can reference them. So, for example, all we are going to do here is we're going to put a counter into all the logs. So you can reference it here, and you can just, whenever you create a new one, you increment it by 1. Something else you can do is you can put, for example, your request ID, right? Or you can put the original IP of the server or things like that. I think that's super useful. More things. Again, slides online. Basically, this allows you to, if there's an error, log the 2 previous debug logs, for example, which is, I think, is super useful. So you can just kind of buffer your debug errors and then, your debug logs. And if there's an issue, you just log them. Otherwise, you just throw them away. Oh, this is a big catch as well in logging. If you use multi-threading, you want to use a queue handler. It also allows you to do non-blocking logging if you want. Basically, what this handler does is just put the log record into a queue. Quite often you get a question of, oh wait, but if there is another handler handling it, I'm gonna see the log, because you can use this, for example, in multi-threading, in multiprocessing. So you can have one process putting logs into a queue and then reporting it to the main process that's gonna log everything. Because you don't want to have multiple processes logging into the same file, right? If you don't know why, there's a whole Linux conference in this building as well. And because you don't want that, you can, for example, use a queue handler. And that will allow you to have a single process logging everything. And many people ask, but hey, if there is a different process logging it, wouldn't it get the line number and the thread number and everything wrong? But we know that's not the case. Wow. We know that's not the case because we know that all that information is in the log record. And the log record is created in the logger. And we are past that point already, right? If you want to get console output, I'm trying to get a simpler way to do it in CPython. But basically, something you can do is, if you want to get console output in the sense of you want warning and above to go to std error, and you want info and below to go to std out, you can do it with this simple recipe. It's basically just using a filter. This is a way to combine the logging configuration for your CLI with our parse. It just allows you to do -v, and you can put as many v as you want, and that will increase the level of verbosity, and you can also pass an output file. Again, I'm going to put everything in this slide. This is just in case. Links. So those are some links. If you want to read more about logging, there were some really good questions in the quiz. And those are some links if you want to learn more about logging. That's an article that explains everything that kind of explained in the presentation. This is the how-to, which is kind of some kind of a guide on how to use logging. And this is they have also a cookbook with some small recipes. And I really invite you to have a look through the code of logging. It's again easy to read. If you have any questions, if you have anything you don't understand in logging, you just can, just throw PTB and try to understand what's happening. And that's it. If we have time on the questions, I'll try to set up the quiz.
Thanks for the kickoff talk. We are really short on Q&A time, so maybe a couple of questions here, but I want to remind that we have a discussion zone outside. There is a flip chart, so you can continue outside after this.
Thank you.
Okay.
Thank you. In your report, you configured several loggers as well as root logger. Mm-hmm. So how do you choose which logger to use when you send a message?
Yeah, so usually, that's something I love about logging, which is that on all your modules, you just say, I want to get a logger for my module. And then it's just going to follow your hierarchy. So for example, requests is going to say, get me a logger requests, right? And then when you are configured, you are the one to decide what each logger is going to do. But at the time that you are logging, you should not worry at all on how things are going to be logged, right? You want to separate those two. You want on one side to say, I'm requests, or I'm Django, or I'm whatever. And I think that this message is with an importance of debug, or warning, or info, and then it should be logging this.
Can you unite logging loggers for external libraries in your own code?
Yeah, that's the. Oh, okay. Wait. What are you saying?
So,
Are you saying I do get logger Django in my app called Super Mario?
So like Django in your own code can log into the same log file.
Oh yeah, absolutely. So you see, when you're logging, you're just saying the message that you want to log, but you don't say where. So it's at the time that you configure it that you say the handler that each logger is going to use. So it's at that point that you say Django requests and everyone else is going to go to this file. So all the libraries are going to log into the same file.
Thank you.
No problem.
Thank you for the talk. We all know that logging supports currently only the formatting with %signs, like %s, %d, %f. And in between, Python supports the curly braces and even now the f strings, which are beautiful and offer much more possibilities to format. I know that you shouldn't format the string before you send it to the logger, but do you know about any intentions or why they are not supporting f strings now?
Yeah, so, okay. So that's why I also said that this can trigger battles. And I've done many times in many situations, and if I'm sure that the log is going to go through. But the reason is because, as we said, that logging is kind of collaborative. There is a lot of code already that are using the %, right? So if you try now to say, okay, I want to use a new format for messages, how do you know which string is using the old one and which string is using the new one, right? There is no easy way to know that.
There is in the configuration of logging, you can, in the format of your logging messages, you can use 3 or 4 different formats, and you can define which one you are using.
Yeah, but what you're referring to, I believe, is the formatter login style.
Formatter, yes.
So that will get that. What that allows you, if you change the login formatter style, it allows you to say. So you saw that the formatter had a template, right? Mm-hmm. So this is the template. Yes. This is the template of the formatter. So you can use f strings and you can use as well string.template here, but you cannot. But that parameter allows you to use them here, but not in your login at the time that you log, because you can change it here because this is the only where it is, but you cannot change it in the other one because it's all around the code, right?
Yeah. Okay. We have to wait for Python 4.
Yes.
Yeah, we actually are out of time, so just go continue in the discussion zone. Thanks,
Thank you.
Mario.
Thank you.